Now we have to find the value of g dash 1 where g dash x gx equal to integration over the lower limit and upper limit, and integrand function is as fx equal to square root of 1 plus 3 x raised to the power 4, and this function is defined for all values of real numbers. So to find value of g dash 1 we need to find first derivative of g. If anyhow we can find the derivative of g, then we can easily replace variable value as 1, then we can easily get the solution. Now to find the g dash x we need to differentiate the function g with respect to x. So gx is defined as integration over lower limit and upper limit of ft dt. Suppose this is not need to be suppose, it is perfectly given x within bracket x minus 2, and this is 4x minus 5. Differentiate with respect to x in left hand side and right hand side also. So this concept of Leibniz rule comes in existing Leibniz rule of differentiation, or sometimes we know this concept differentiation under integration. According to this rule, we need to replace integrand function variable as a upper limit and need to be multiply with derivative of upper limit. Derivative को derivative of upper limit minus replace function variable with lower limit and need to be multiply with lower limit derivative. According to this concept, I can write g dash x equals to f of 4x minus 5 and product with 4 because of derivative of upper limit is 4 minus f of 4x x square minus 2x with product 2x minus 2 means lower limit derivative. This value is equal to, now we need to calculate value of g dash 1. G dash 1 will be 4 f of minus 1 minus f of minus 1 into 0. So finally this term will go to 0 and remaining term will be 4 f of minus 1, and function f is given as fx is given as square root of 1 plus 3 x raised to the power 4. So from this one, f of minus 1 equals to 2. So 4 into 2 means 8 is the correct answer. Sometimes the Leibniz rule over integration is generalized as d of dx integration from lower limit ax and bx. The necessary condition for ax and bx means the lower limit or upper limit is that these limit must be differentiable. Must be differentiable means need to be continuous, but continuous doesn't imply differentiability, so lower limit must be differentiable, and this function integrand function either in one variable or two variable must be continuous. So we can replace function variable with upper limit and need to be take derivative of upper limit and multiply them. Similarly for lower limit and need to be multiplied with derivative of lower limit plus integration of partial derivative of f, and this partial derivative with respect to as limit variable. So this is generalized form. Sometimes when function is single variable, then we can easily write this as This term will go to 0, and finally we obtain only two terms, f of x bx into b dash x minus f of x ex into e dash x. So this last term becomes 0, and finally we obtain the answer.